Welcome to the last block of this conference. And this block is called Tools for Next Steps. I will be the moderator of this block this afternoon. My name is Rodolfo Souza, and I'm the head of Metrology, Technology, and Communication Division in Metro, Brazil. And also I'm the coordinator of the Cloud Metrology Group for the team, Metrology Working Group 14. This block, Tools for Next Steps, we really don't know what is going to be the future with digital transformation. The technology is evolving quickly, and a completely new paradigm with AI, Internet of Things, and other probably will change completely our lives as the internet and the mobile phone did before 10 years ago. One thing to notice is that we are always interested in new things, in new services, new features, new things. But we forget sometimes the importance of to guarantee that these new features are safe and don't have security flaws or security hazards that could affect us. For instance, 10 years ago, the people say the IoT, there will be 10 billion, more than 10 billion devices, IoT devices on the market by this year. And we see that this is not true. The adoption of IoT is very low considered the prediction. One thing, there are other problems, but one thing is the security. When you install an IoT system, we get a very big and a very problematic security question. Also, AI is everybody discussing AI nowadays. People say we have to consider the safety of AI. There was a letter this year again asking for breaking the velocity of the AI systems to keep cope with security reasons, and also the alignment of the AI to prevent any harm that this could do to the people. So it's this always when you open a computer system since the beginning, since back, even before the internet, the virus starts with the disk drive. We put a computer system in something, and we also have a security concern and security hole that be fixed. For that, we don't suffer from the good things that they are bringing. And this afternoon we are discussing some aspects of cybersecurity, some broad aspects, blockchain, digital signature, biometric. These are technologies that are very important in this brave new world, and we are going to discuss this today. The first speaker we invite is Professor Luis Fernando Rushi Carmo. He has electronic engineer and Master of Science in Computer Science from Federal University of Rio de Janeiro, PhD in Computer Science in 1994 by the Systems Analysis and Architecture Laboratory of the French National Organization for Scientific Research in Toulouse. From 2002 and 2003, he spent a sabbatical at the United Technology Company Research Center in Connecticut, USA. From 1986 to 2008, Luiz Rucci was an active member of the research team at the University Federal of Rio de Janeiro Computing Center. Since 2008, he's a senior specialist at the Brazilian Institute of Metrology and Quality in Metro. And currently, he serves as a director of scientific metrology and industrial technology in Inmetro. Inmetro concentrates all the quality infrastructure of Brazil, almost all, and the NMI of Brazil is the director of the Inmetro that Professor Rucci is now the head. He also is the head of the academic council of Inmetro, and his research interests include information security, software validation for embedded systems, and digital transformation for metrology. Thank you, Mr. Luiz Rucci, for supporting the M4Dt Conference, and you can go ahead to speak.
Right. I'm trying. I need to load my presentation. How can I do that?
Yes, Francisco, you could promote Professor Rucci as a presenter.
Just a moment, but I think that he has the right.
Yes, you should press compartilhar tela or share the screen.
And you are co-hosting, Rodolfo.
Yes.
Okay, let me see.
So.
Okay, I see your screen.
Let's.
Do you have a camera? Your image is black.
It's okay now?
Let people see you.
Just a minute. Let me see where is. So that's all my video.
Here we can see your presentation, but not
we
your
can see
video.
your presentation, but not your video.
Oh.
Maybe is there something in the cam because it's as if you were projecting, but it's all black.
I try it again. It's not working. Yes, there is some problem here.
Yes, but you could. The
Okay.
video is not open, but you could start. We could see your screen if you could put on the presentation mode.
Yes, okay.
Okay.
So, good afternoon, everybody. Thanks a lot by the invitation. It's a great pleasure to be here and talk a little bit about cybersecurity on smart meters. As Rodolfo said, my name is Luis, and for the last 15 years, I am working in metal, right? So what I prepared for today is to talk very fast about some motivations and try to give some concepts about security on smart meter, right? I just want to make a point that this is very different from information security as a large concept. And I will propose three different control types. The first one, I call it shielding meters. The second one is secure measurement functions. And the last one is post-processing tools, right? I talk a little bit about challenges and conclusions. So motivations, I think that everybody shares what I resumed here. We have now Industry 4.0 and Internet of Things. It means we have billions of sensors, actuators. We have a real-world image reproducing the virtual, software-defined measure equipments, new magnitude to be measured, new ways to achieve traceability, right? And we know that all those things, if we have some kind of attack, we're going to have some great damage in industrial facilities, cities, and the worst in critical infrastructure. So we need to have trustful data. This is fundamental. And what I want to say is we can have trustworthiness using more what we call digital transformation, right? This is my point. Normally, when we talk about security on smart meters, we don't realize that this is different than talk about information security as a whole, right? Information security, we have a generic data semantics, and when we talk about smart meter, information now is equal to measurements, and so we have specific data semantics, right? And if you know that, we can handle our security controls in a better way than we do for information security generic, right? So I'm gonna talk a little bit about those three different security control types. I'll do that by showing you some examples, okay? And we can discuss a little bit about that. So let's understand what is shielding meters, right? Normally, if we talk about legal metrology, we need to provide society with the necessary means to establish confidence in measurement results, right? So normally for that, we use the type approval process, and normally we need to evaluate the meter architecture and its operation, understand the operation of meters, the algorithms, protocols, communication interface, full picture of declared feature comments, identification of legally relevant parties, information security requirements, and also the test case, right? The best way to do that is to verificate the relevant software source code, right? But we all know that it's a very hard work, and we need to use some evaluation tools to make the software integrity be developed, right? So let me start with an example. In Brazil, we had a big problem with an unfavorable scenario for non-technical loss. And the solution at this time, this has more than 10 years, but the solution was to get the house meter and put it on the top of line pole, right? This is going to be less vulnerable for energy theft. At this point, we didn't have any specific regulation, and we used the same regulations of conventional meters. But doing that, changing the meters of inside the house to the top of the pole, we start to have a drop in loss, right? So, what was the situation? The problem is that the manufacturer developed this solution doing a kind of post-installation software debug approach, right? And we also had a lot of different software versions embedded in the meters. The consequences, we had a lot of insecurity and dissatisfaction among consumers, and a high number of erroneous invoices caused by simple configuration errors. So we decided to make a specific requirements for this new architecture. And the first thing that we decided to do is we had to use a display inside the house. Even that the meter is on the top of the pole, we need to have a display inside the house, right? So with that, we can establish a legally relevant chain that starts from the sensors, right, in the top of the pole, and this finish with the information being displayed to the customer. Okay, and we need a very strict control of the embedded software, right? But for doing that, we need to use a lot of integrity verification, soft authentication. We propose some software protection using tamper-proofing. We use some software traceability tools for trying to make the correspondence of the source codes and the execution codes. We need to evaluate all the vulnerabilities of the software. And even we propose to use some crypto coprocessor with hard roots of trust and with a suite of cryptographic algorithms, right? And again, we get this requirements and use it in another product. This time we are talking about time clock. This is to register the in and out of an employee when he starts working and stop working, right? So this is not metrology, legal metrology. This is conformity assessment. But we know that there is a lot of interest in correctness of these clocking registers. So it's important to protect time in, time out, right? And we need to have authenticity, availability, integrity, repeatability. But this was good because we had now not only one product being evaluated, but now we start to have several products. This is another product, and we start to use accredited labs to doing these jobs. But let's think about other ways to ensure security, right? This second type, I call it framework to control measurements. So the idea is to generate, collect, and process of security control evidence. Yeah, and this is typically used in complex systems for measuring, right? When we talk about complex systems, it's much more difficult to make, for example, a source code evaluation, right? So the idea here is to use other information, to add some information like photos, intermediary values, redundant information, and to improve security processing those new information. Let's get an example. Here I talk about the transport of dangerous goods. Inmetro is responsible to evaluate the inspection bodies, and we also use it to have a lot of problem with inspection body. Those inspection bodies, they need to evaluate, follow the sets of requirements, a lot of information about the box truck where you're gonna put these dangerous goods, and we need to be sure about that this work was being done, right? So what we decide to do, we decide to use new information, so to propose a framework to control this process, right? We start to use image for each party of the evaluation, and we got this image, these photos, and we also add time, position, and a digital signature. With that, we could verify a posteriori if all the work had been done, right? So now we have a lot of evidence that each of those different evaluations had been done. And for doing that, we also made what we call plausibility verification, right? Because we can say that some part of the evaluation cannot be done together with another part, right? So we have a partial order that regulates the execution of this evaluation, right? So we've done that, and this is a good example of building a framework to improve security, right? The last type that I want to talk about is the post-processing tools that we can also realize. So we know that data for us is measurements, right? And if we have a lot of data, if we have all the database, we can use that to see if there is any clue about this process is being found or not, right? Let's see some examples. The first example is we use this to detect suspected patterns of fraudulent behavior in vehicle emission tests performed by an accredited inspection body, right? And this was a very simple test. We got all the results and see if the distribution was something normal or not, right? And we had some very good results doing that. Another example, and here we using AI is to get the data of breathalyzer failures and try to use a machine learning model with classification clustering and see if the meter would be a candidate to have a fail before the next verification of the meter, right? So we got something like 75 accuracy, but this was not a real fraud, right? This was a training for looking for some fails, but we can do the same thing to verify if we have fraud or not, right? So this kind of voice processing is also a very powerful tool for improving security in a quality infrastructure, right? Let's see some other examples. Here we talk about a project with a hydroelectric plant here in Brazil called Belo Monte, right? It's a big hydroelectric plant, and what we did here is to use PZT sensors to monitor hazard events in the dam and slopes, right? I will not talk about this, but I will talk about the cybersecurity. So we need to have some trustful information, and we need to ensure that sensors were delivering good information, right? So we need to guarantee data integrity and authenticity, and provide traceability and also auditability, right? So what do we want? We want to have a kind of unique identifier based on the sensor's physical properties and have, after collecting those information, a reliable and immutable storage using blockchain. Okay. Sorry. So, and you can ask why you didn't use a digital signature. The problem is that the sensor you don't have enough resources to do that. So we need to get some kind of information that identify this sensor, right? Some kind of property that is only of a given sensor, right? Another example to improve security is a project for the food dispenser smart surveillance. The question is, do you trust fuel pumps? And here in Brazil, we have a new requirements for the fuel pumps to use digital signature. This is a good good idea, but we can think about other ways to also improve security. We know that fraud against fuel pumps is a widely disseminated practice, right? And we know that traditional surveillance and inspection activities are no longer effective. That's why we start to use now digital certificate to those fuel pumps. But we can think about another solution that we know that vehicles can help with fuel pump inspection by using embedded sensors to estimate the fuel amount on each refilling, right? Although those sensors have a significant measurement uncertainty, when many vehicles refuel in the same pump, the error average converts to the correct value due to the law of great numbers, right? So we make some simulation about that. And doing that, we can increase surveillance readability, right? So this is it's another way to improve security and not doing only the classical shielding the meter, right? So how to implement this solution in practice? We know that vehicles use the OBD interface. All the vehicles now have a OBD interface, and we can access sensors already available. Drivers can use an app to collect data by Bluetooth, and we use a blockchain, right, with smart contracts to get all those information. And we can have independent organization in fighting against those frauds that would provide this infrastructure that we need, right? So I talked a lot, but what I want to say that we're gonna have a lot of challenges in the future, you know, well, right? The first one, we need to follow the discussion about quantum computing. So this can change all the algorithms that we have been using in the past decades, right? So this is a great challenge, and we need to pay attention to that. We also have the problem of artificial intelligence, right? It's mandatory to have rigorous scientific tests to ensure reliable and safe AI. Okay, we need to have a broad spectrum of standards for AI data, metadata for training, validation, use case and best practice guide, audit to track the output of an AI system. So this all is very critical, right? Oh, sorry about that. Oh, I didn't understand. So my conclusion is we have needs to disseminate competence on information security, and information security more oriented to quality infrastructure. That's a little bit different to training at all levels. To have training at all levels is also very important to follow technological evolution, right? With all the main international players, and we need to encourage the development and adoption of security solutions. Here in Metro, we have initiated a technical course in cybersecurity. We also have a first-level certification authority for metrological objects, and we are always looking for new R&D projects in security. That's it. Rodolfo.
Thank you, Professor Husti, for your presentation. Very good presentation and interesting. And I will ask you to stay with us until the end of the block to answer the questions from the audience. And now we are going, second speaker we have to this afternoon is Mr. Eduardo Machado with the presentation, A Security Architecture for Implementing Distributed Measurement Systems, the Breaking Tester Case Study. Eduardo is a PhD student in the postgraduate program in metrology at Inmetro and master's degree in mechanical engineering. He has been working with ISO 1720 accrediting inspection bodies for over 10 years. He is engineer-in-chief advisor and auditor, currently researching cybersecurity of measurement systems in collaboration with Augitech and founded by the FAPERJ, Financial of the State of Rio de Janeiro, the Research Financial of Rio de Janeiro. Also, this presentation will be shared with another people, another person. Rafael Gomes is a bachelor's student in computer science at University Federal Fluminense. Currently, Rafael is in a scientific initiation project researching cybersecurity of measurement systems at Inmetro, also founded by FAPERJ. Thank you very much for being present at this event, Mr. Machado and Mr. Rafael. You can start your presentation.
Good afternoon. We are grateful for the invitation and the opportunity to participate in M4Dt. My name is Eduardo Machado. I am a PhD student at Inmetro's postgraduate program in metrology. And today I'm honored to be joined with Mr. Rafael Gomes, a member of our research team, to co-present our research in security of measuring instruments. The focus of our presentation revolves around a novel architecture framework designed for measuring systems. This framework is characterized by its three-tiered approach to cyber-physical security, a novel arrangement that ensures the integrity of measurements deemed critical. Furthermore, we will delve into a case study involving a force gauge employed in vehicular applications. I will present a concern of the current state of road safety in Brazil. With over 59 million vehicles in circulation, the country witnessed 64,000 traffic accidents. Among these, more than 72,000 incidents involve injuries, with an alarming count of over 5,000 fatalities. The significance of these statistics underscores the importance of addressing road safety. This data demonstrates that our roadways could become safer. Contributing factors to these events include driver distraction, sometimes motivated by alcohol or drugs, and notably inadequate vehicle maintenance. In response to the global imperative of enhancing road safety, the Brazilian government has taken proactive steps by introducing a national program for security traffic management. This program, planned to develop until 2030, includes a set of specific goals. The implementation of vehicle safety inspection for the entire fleet is one of those goals. The principle is to subject vehicles to periodic assessment, evaluating critical systems such as lighting, suspension, brakes, and tire conditions. This imperative initiative reflects the dedication to creating a safer driving environment. In the present day, some vehicles are already undergoing this type of inspection. And we have brought some examples to provide context. Vehicles propelled by compressed natural gas, who transporting hazardous goods, vehicles that have undergone repairs following accidents or modifications for their original design. For example, vehicles tailored for accommodate a person with disabilities, the addition of a sidecar to a motorcycle, or a transformation of a van into RV, or even the alteration of an automobile suspension system for aesthetical purposes. To validate the updated documentation of these vehicles, they are required to undergo a vehicle inspection in an accredited body. In this image, we can observe the inspection station where the battery of tests takes place. This process entails visual and mechanized inspections, designed to ensure vehicle safety and compliance with traffic regulations. In Brazil, there are over 500 inspection bodies accredited by Inmetro. Typically, these inspection entities are equipped with 1 or 2 devices designed for measuring the braking systems of the vehicle, aptly named roller brake tester or just brake tester. In this image, displays an axis of the vehicle positioned on the brake tester, ready for evaluation. This equipment is compressed by 2 sets of rollers, and it's commonly installed below the floor and evaluates 1 vehicle axle at a time. Each day, more than 5,000 certificates are issued. It means that annually there are over 1.5 million inspections employing the braking tester. A curious thing is that each brake tester carries an approximate cost of $40,000, implying that proposed adaptations to heighten the instrument security levels could potentially yield marginal economic impact on the final value of the product. However, a big challenge confronts this instrument. Inmetro frequently receives complaints of fraudulent manipulation of the brake tester, enabling vehicles to secure approval with undue ease. Malicious customers seek undue advantage by engaging in fraudulent practices with the inspection bodies to manipulate the braking test data and secure approval for the vehicle. Inmetro shoulders the responsibility of safeguarding the reliability of these measuring instruments, ensuring they provide a society with data that can be trusted. In a typical setup, the brake tester is outfitted with a total of 10 sensors. These sensors are load cells. On either side, 4 sensors are positioned to gauge the vehicle weight, or a vertical force. An additional sensor is connected to the electric engine, and it's dedicated to measuring the braking force exerted by the tires on the rollers. These sensors operate cooperatively, and it constitutes in a distributed measuring system. Opening a brief parenthesis, we have seen that different authors propose different meanings for the term distributed measuring system. But in general, we can say that DMS are arrangements that utilize multiple unities dedicated to measuring. These unities have communication capabilities, and this kind of measuring system sometimes can be targets of specific virtual attacks. The attacker manipulates 1 or more units of the network to alter the operation of the entire system. There are also risks related to fraud in the calculation logic and processing in instruments composed of multiple measurements. But now returning to the brake tester, let's see how the calculations are performed to obtain the measurement result. This DMS finds its application within conformity assessment entities, primarily to evaluate two fundamental factors: the total braking efficiency and braking balance of the vehicle axles. From the data captured by the sensors, the vertical force and braking force for each wheel, the software performs these calculations to find braking efficiency and braking imbalance. Braking efficiency represents a vehicle's ability to stop when it's requested. Defined limits are established by regulations. Heavy vehicles must attain a minimum of 50% braking efficiency. Light vehicles should surpass 55%. And parking brakes must demonstrate at least 18% efficiency. Conversely, braking imbalance implies both sides of the vehicle are braking proportionally, ensuring that one side does not apply more braking force than the other. This ensures that the vehicle avoids excessive torsion during braking. The stipulated regulatory limit for imbalance is 20%. So today, how are the brake testers built? The system has two measurements, the vertical effort and the braking effort. They correspond of the physical variable measured at each wheel of the vehicle. Those physical variables are captured by the load cells, and they are responsible to convert the force signal into an analog signal. A PLC or a microprocessor board amplify and transform this information into a digital signal. The data is received by a computer to processing the information and performing the necessary calculations and storage the results. The outcome of this process is the information whether the vehicle has been approved or rejected, as well as the values of the braking efficiency and braking imbalance.
This architecture is based on three phases: sensing, which involves capturing the measurement and guarantees authenticity by digital sign; the realization of the measurement, which encompasses performing the calculations within the blockchain network and guarantees information transparency and its availability; and storage, where the measurement cannot be altered or even removed from the network, preventing a fraud. By storing the information on the blockchain network, it remains both accessible, integral, and transparent. Our proposal to increase the level of security is that after the measurement is captured, it will no longer be received by conventional load cells, but by a smart meter, where it encapsulates some of these actions, such as sensing, signal amplification, and signal conversion. The reason for encapsulating the functions of the sensor into a single component is to reduce the potential attack surfaces. Additionally, a new layer of security is added to the brake test, involving the insertion of a digital signature in a safe zone of the smart sensor's processor. Then, the data sign is sent to a blockchain network. Blockchain is basically a decentralized and secure digital ledger. It ensures transparency and immutability of recorded transactions. Blockchain enables a new level of trust and collaboration among participants without the need of intermediaries. Our purpose is, if there are more than 500 inspection labs and other entities interested in this measurement, they could be responsible for storing this information and performing the process to determine if the vehicle is approved or not. Subsequently, like in traditional instruments, the result of the process is displayed. For the experimental part within the smart meter, we can use a trust execution environment, which is an environment already present in ARM processors, known as ARM Trust Zone. Trust Zone includes an operating system called OPT. There are two options to execute our architecture. The first one is to emulate the architecture using QEMU, and the second one is transitioning to a hardware setup using a Raspberry Pi to develop the codes that will perform the certification of the measurements. We are drawing examples from the literature, employing a cryptographic algorithm like RSA. The signed measurement reaches the blockchain and the experimental phase is conducted using Hyperledger Fabric. It holds the advantage of being a permissioned network where only authenticated organizations participate. Smart contracts are responsible for realization of measurements, performing calculations based on simulated values. We believe the organizations with an interest in participating in this network would include Metro, the Ministry of Transport, inspection bodies, IT companies, and brake tester manufacturers. So, the brake tester captures this physical variable using this new component, the smart meter. The smart meter could be composed of 5 modules. First of all, the transducer is responsible for converting the physical variable into a digital sign. In the processor, there are 2 kernels, the safe area and normal area. It's called trusted execution environment. This is where the significant difference occurs between a regular sensor and our architecture. In the safe area, it's possible to implement an application that performs a digital signage to ensure the authenticity of the brake tester sensors. This is done in an environment that is more protected against intrusion. The information is transported to the normal area of the processor. Using the connectivity module, it sends the signed information to a blockchain network. Inside the blockchain network, we're representing 2 organizations in this image, one representing Metro and the other an inspection body. The communication occurs using the channel. In the blockchain world, smart contracts automatically execute actions or transactions like softwares. We have brought some examples of smart contracts in our context. We can use them to record the measurements on the ledger, to do the realization of measurements, to issue the report of inspection if the vehicle were approved or not, and moreover, some participants in the network can audit all the information.
The main challenge we face are the concept of DMS is still missing a clear definition in the literature. And different authors have many definitions for this term. Therefore, it's essential to harmonize this concept for better comprehension. TE is a challenging technology to utilize. Despite the presence of ARM Trust Zone in many devices, it usually remains inaccessible for programming. Developing application for Trust Zone requires specialized programming techniques, and not all platforms have full support for TEE technology. And the successful implementation of a blockchain technology relies on the collaboration of the inspection bodies. So it's important to establish steps to ensure participant engagement, which can be rewards or regulatory determination. Finally, our next steps is to move away from a simulation model and proceed with the development of a real smart meter. And we pretend to test this smart meter on a real brake tester and validate our architecture. And behind the scenes, we have our supervisor, Dr. Wilson, and Mr. Eduardo Valente, who helps us to prepare this presentation. And we want to thank them. Also, we want to thank the organizations who funding our project, FAPERJ, Algitec, CNPq. And thanks to you for your attention and this presentation. And thanks again for M4Dt organizers.
Thank you very much, Eduardo and Rafael. I will ask you to continue with us until the end of the block to answer the questions from the audience. And now we are going to the next presenter, the last presentation of the day, called Platform-Based Service for Digital Metrology by means of Distributed Ledger Technology, which will be presented by Frederico Grasso. Dr. Engineer Frederico Grasso Toro, electronics engineer, oriented to automation and robotics from UNSJ, Argentina, and a PhD degree in mechanical engineering to 2014, oriented to AI for GNSS-based localization systems from TU Braunschweig, Germany. These words in German is hard to spell. Since 2016, he works on the digitalization of metrology in the NMIs like PTB, Germany, and Meta, Switzerland, as well as external consultant at Grasso Toro Digital Solutions. He is currently data steward at the University of Bern, Switzerland. Thank you, Frederico, for your time. Welcome to this 4th annual conference, and please go ahead. Thank you.
Hello, everyone. I hope you can hear me and see my screen. Can you confirm this?
Yes, yes.
Okay, good. So it's been a bit of a mistake regarding the title, but it's okay because the title is there. Just to make sure that everyone knows, so my name is Federico Grasso Toro, and I've been working in digitalization of metrology for a few years now, but now I'm mostly oriented in trying to provide external consulting to NMIs and RMOs. So I'm very glad that I have the opportunity here in a RMO level conference to be able to actually provide interesting points of view of where the future takes us. The title officially is the development of digital trust by cloud-based platforms in an RMO level. So basically the idea is to figure out how we will do the digitalization of trust. That is just basically the main task or the main feature of metrology currently. And my subtitle is on how distributed accumulative trust, that's the technology that I'm proposing, can aid the digitalization of metrological services in an RMO level. So with all that said, here we have the content, or a very summary of the content. Basically, I will do an introduction to digitalization as I typically do. Just in this case, because I found that it's great that I'm just the last presenter, I would enjoy just detailing how each of the levels of the digitalization process have been already tackled during these 2 days. But the main question that I find necessary to answer hasn't been mentioned up to this point. So for that, I would put a little bit of pre-designed concepts that are on the table right now, just to define what are for me, the further steps for research and development in the digitalization of metrology right now. Then I will do some sort of analysis of what's going on in the IPM level in order for me to be able to suggest what in the RMO level should happen. And last but not least, I will explain this technology called distributed accumulative trust that I've been studying, and I believe is probably the best way forward to digitalize trust as part of the features of metrology. Finally, some partial conclusions and some open topics. So as I always said, digitalization is not digitization. Sorry, can you hear me?
Dr. Frederico, your presentation is not on presentation mode.
Oh, okay. So I should switch
Thank
it
you.
like this. Is it like that now?
It continues in the.
Let me reshare my screen. I'm sorry. Here it is. Can you see it now?
Perfect.
Is it in presentation mode? Yes?
Yes.
Do you see content now? Okay, good. Sorry, I was clearly sharing the wrong window. Now, as I said many times, digitization is not the same as digitalization, and that's not the same as digital transformation. while the first steps of digitization, we've seen some examples in the last 2 days, had to do with digitizing the information or organizing the information. What we call digitalization tends to be the automatization of processes or the streamlining of processes. Basically, that's what I always mention as the use of digital technologies in order to create better described markets. And then last but not least, digital transformation in itself is basically the overall transformation of an institution. And that's the part that I'm aiming for. That's the part that I would like today to suggest where are we going and how we're going there. So as I said, I will mention a couple of pre-designed concepts that I've been mentioning for the last few years as part of the digitalization of metrology. We need to stop thinking as the environment in one side and the machine in the other side. We need to start including the human in the loop, as many people call it. That implies that once we consider systems to be controlled, systems to be designed as human plus machines, we have something that typically is called maybe I can point at the thing, the missing middle. Basically, this what it means is we're going to have the possibility of considering how to develop systems that are humans complementing machines, while at the same time humans being provided additional capacities by machines. So that hybrid activities is the point of view for me that has to be the most significant for the consideration of digitalization of technologies, but specifically in this case, metrology. Meaning that as a human plus human system, basically the most regarding that we've been dealing with regarding digital trust, the most significant advance that we've been doing is we're pushing to a novel way of communicating machine to machine. And that probably, and you've seen a few examples yesterday and some today, adds to the potential of the digitalization of all the aspects of the quality infrastructure. So this is what people tend to call the digitalization of quality infrastructure. But meanwhile, on the other side, the World Economic Forum is pushing the idea that we need to establish digital trust services in order for people to trust technology, but also in order for service providers to provide additional security, not just at IT securities like we've seen before, not just as cryptographic security as we've seen before, but also the overall feeling of trust from the point of view of the end user. So those two things are pushing parallelly, let's say, and the most important thing is to make sure that machine to machine communication would allow these two advances to move forward. But what does that mean for metrology, and specifically or more generally in quality infrastructure, is we consider the quality infrastructure typically relying on what we call metrology, standardization, accreditation, conformity assessment, and market surveillance, and so on for specific regulated areas. As we've seen in the last couple of days, in all of these aspects, there have been digitalization efforts. And that's great because that allows us to say that we're aiming for the digitalization of quality infrastructure. But regarding that, there's the need of digital trust implications for all of these advances. And what I put here, just a very general, in very shortly summarized way, is that metrologically speaking, the digital processes are going to have metrologically relevant aspects, such as the digital representation of objects. We've seen examples as well of that. Remote services, we've seen some suggestions and mentioning for market surveillance as well. And we have to consider now always the dynamic software modules as aspects of potential decentralized measurement instrument or distributed measurement instruments that we've seen in the previous presentation. So that aims towards a semantic of human plus machine systems. We also saw some examples of how semantics affect the way that we actually evaluate parts from the quality infrastructure. And all of that, at the end of the day, ideally would have us towards a machine-to-machine communication for an overall market surveillance of all areas. So for that, then we have to define what do we do from metrology through the digital trust to aid this quality infrastructure and specifically the digitalization of quality infrastructure. And for that, I broke down the well-known pyramid that we know from SI to BIPM to then the RMOs, then NMIs and laboratories, and eventually the end users in the industry level. And from that, I thought, how can we focus specifically to define digital trust in a regional level? So firstly, what we would say is like, what's going on digital trust-wise in BIPM level? And what we've seen, and we saw Janet presenting some stuff yesterday, is that there's existing development to modernize or digitalize better the key comparison database. And that in the short term means that the key comparison database now has some sort of API for machine-to-machine communication. But at the end of the day, it ends up being just basically an SQL with digitalized CMCs with the additional key comparison reports. So future states would mean that eventually, not only that, but of course, digital representation of SI, or maybe as mentioned yesterday, as Sean mentioned, maybe unique identifiers would allow us to verify specific capacities in a very general way. So my question is, how do we move towards that? Because towards the future of specific services in more regional level, because I just described, this is just BIPM, and this focused basically only in CMCs. So for a summary, I would say that at the end of the day, a digital trust from the point of view of the key comparison database will only be basically the relational database that we have, with more specific machine-to-machine communication aspects, such as machine-to-machine communication for APIs, machine-readable CMCs, and even probably the machine-readable results of scientific comparisons underpinning these CMCs. So that is great, because that's literally the goal and the function of BIPM. But I believe that is not enough to actually converge all these advances or all these digitization efforts that we've seen lately. So what I would say is, like, we need to focus a little bit more in the RMO level. And for the RMO level, what I'm suggesting is to slowly develop the possibility of intercomparison databases in an RMO level. That can be easily solved by a cloud-based platform in a regional level, as I said, that would have specific needs related to that region. So that advance the speed of evolution or innovation within the region, depending on the needs of the region. So RMOs from GulfMed do not have the same needs of the RMO from APMP, so Asian Pacific, and so on. So the idea is focusing on that. How can we define a clear digital trusted e-service on the regional level? And for that, I'm suggesting an only SQL database for the digitalization of RMO services. But mostly important is the base of that is the distributed accumulative trust. That is the technology that I would like to explain a little bit later. So the potential implications of this would be not only the additional machine-to-machine information that is also being developed in BIPM level, but also that would allow us to communicate BIPM to RMO, but also RMOs to NMI. So basically, we continue the let's call it the metrological tradition of this pyramid, but now in a digital way. But also, since we are being able to create a platform in a regional level, we would have the possibility of creating client queries in a level of RMO to lab, in a level to RMO to NMI, or in a level even to end users to specific labs. So the idea is we need to properly distribute or properly represent the trust that metrology has been doing for many years now, but in a digital way. And that hopefully will allow us to have a fully traceable digital trust by machine-to-machine communications in a regional level that is always verifiable by machine-to-machine communication with the BIPM level. So that would imply we need to revise or reread basically what are the actual tasks of the regional metrological organizations as they are. And if we check them specifically, you would see that basically the role of the RMOs are basically to make proposals for the CCs, that are basically whoever coordinates whatever is happening in the key comparison database, from the point of view of the key comparisons, but also to carry out supplementary comparisons and other actions designed to support mutual confidence in the validity of calibration and measurement capacity. So basically the CMCs in more regional levels. So what I'm thinking here is we should focus not only in providing machine-to-machine communication just to make sure that we can validate the CMCs that already exist in the key comparison database, but maybe we can add on to specific requires or specific needs from the point of view of the region. So putting that in that regard, what I would say is region-wise, we wouldn't need a relational database, but a non-SQL database that will allow us more flexibility and more dynamism to compare specific requirements for specific needs in the region, allowing, let's say, new labs to provide additional value and additional services, while all labs that have not enough budget, let's say, for digitalization aspects, to use those services through this platform that would basically would put the level of the region similarly, let's say. So for that, I'm suggesting a proof of concept, for example, in a SIM level as an intercomparison database that would be fully focused on the revised technical metrological working groups requirements in order to not just consider what we know for now as CMCs, but what I call CMCs plus plus, that have additional requirements related to the needs, the specific needs of the region. That as well, because we are in a digitalization process, it would allow us to have those intercomparison reports in already machine-to-machine transmittable way, but also additional machine readable information that would have direct correlation with those additional requirements from the CMCs. And that, of course, because let's go to the obvious requirements for basically a cloud-based platform, would additionally have IT security aspects for integrity, authenticity, and confidentiality, and the client platform, because at the end of the day, this web platform, this cloud platform would also provide service to end users, so all levels, let's say, for the region. And last but not least, what I call the distributed accumulative trust, that finally, because I said it already twice, the third time's the charm, now I will explain what does that mean. So if people have done research at some point, they know what ORCID is and how ORCID basically is a way of enable transparency and trustworthiness connection between the researchers that do the research, their contributors, and also any affiliation such as the universities where they study, or also the proper funding systems that they are receiving fundings from. So basically, at the end of the day, the idea is to have persistent identifiers for individuals, and from there, to create something that they call distributed accumulative trust, that is just basically allowing most levels to provide the amount of information to be trusted in their own level and not in the overall level. To explain it very quickly, the difference between a traditional centralized trusted model is that just basically have a gatekeeper. In this case, let's say it would be something like BIPM. If the CMC is in BIPM, you can trust that lab. That's it. There's no more questions about it. But the key comparison database does not have all additional information that you might need as a customer to find the lab. So that additional information is whether you trust it or not, but has nothing to do with how the system of trustworthiness has been built. So this is the classical way. In a new distributed accumulative trust model, what happens is each section, so let's say the lab, the NMI, the RMO, or even BIPM, provides a distributed trust layer that validates the one before, meaning I can trust the information that the lab has given me because it's been provided by the lab, but also because by affiliation, the related NMI has validated. Examples like this would decentralize something that, for example, I put the example from Argentina's traditional centralized trust model that is called CIGEVA, that is everything needs to be through that whole system for researchers. So the idea is, think of this distributed accumulative trust as the new way of thinking trust digitally. And what would happen is, if I need a specific service that I only require to trust the lab, let's say I need to check which is the address of the lab, I can use through the platform in the RMO level just information that I require from a very basic level. I don't need to go to BIPM just to confirm an address, because in the web service through the platform, any user can validate the information that has been provided in that way. Now, what about if I want to have additional information regarding some sort of sensitivity for a specific device that has not been included specifically for a CMC because it's outside of the CMC that has been reported for the lab? That additional information can be provided, hosted, and even validated by the RMO level. So everything would come from the same platform, so from the same cloud-based platform in a regional level, but different levels of trustworthiness would come from different levels of type of service. So from the examples that we've seen today or even yesterday, many of the services that might be provided by the lab or by the NMI have to be digitally trusted. And with this system or with this technique, any customer through an RMO level intercomparison database can trust or can be provided the trustworthiness needed. So that's basically the description. So just to close down a little bit the presentation, what I'm trying to summarize here is that I consider in the RMO level, an intercomparison database would be the perfect next step to move towards the full digital transformation of metrological services, because that would sort of close the gap that we are having right now about any advances for digitalization of the point of view of BIPM and any need from digital trust from the end users in all the other levels from the pyramid. And then the technology of distributed accumulative trust will allow us not only a worldwide adoption of scalability, just like ORCID has become the de facto standard for identifying researchers. Again, very important to say is that ORCID is open software and is extremely well known and extremely well trusted. But that would translate perfectly as the metrological trust that we always had, but into a specific recorded accumulative trustworthiness in a regional level. So that would be, to me, the two main reasons for why I'm saying the digitalization of trust for metrological services needs this as the next step. Now, how that would be, because we are here in SIM, from the point of view of how to redesign or how to think and design a cloud-based solution for SIM, would be first to define some sort of scalable proof of concept that would consider and non-SQL in a regional level with the options of the potential e-services that labs would be interested in being provided, users would be interested in receiving, but essentially what in a level of RMO, the region would be interested in having. So that is the point of view. We've seen a lot of examples of digitalization services in different labs these 2 days. Those are, let's say, the first ones in the list to be considered as regional e-services. Then my suggestion is, if we start with this SIM level model, then we can use everything that we learned during the development of this as good practices for an RMO level demo, providing these novel technical requirements. So that would be additional information from BIPM, from example, from the digital representation of SI, for verification through CMCs, but also the additional information that would come from the digitalization of metrological services as required for the region, as well as all this, let's call it accumulative trustworthiness provided by the region. And so, but last but not least, these novel CMCs, I call them CMCs++, so it could be basically a digital CMC, would have to follow specific requirements from the technical metrological working groups, but also from the task force that we've seen a few task force in the few days from the Metrology for Digital Transformation group here in SIM. So we need to consider what the experts consider the minimum requirements in order to develop these novel CMCs, because following that, we would be able to provide electronic services or e-services, always providing machine-to-machine relevant information. So basically, the development, I see it in, let's say, 3 milestones. That would be the digitalization for intercomparison and key comparison reports. So for the region intercomparison, but also to provide key comparison reports at BIPM level. And in the RMO level, as a platform, it would be the new way or the new one point to find digital trust. May that be digital products as intercomparison verifications, but also may that be the digital trust of services provided not only by NMIs, but also by primary labs and so on. So basically, that is it. Thank you very much for your attention. I hope I didn't last too long.
Thank you, Frederico, for sharing such an interesting experience. To this section, this block is very dense, a lot of things. We are going to start the questions and answers block, just like the previous block. There is a link in the chat. Let me put the link. Wait a moment. To a survey about some questions on this Wait a moment. I think it's for everybody, but I put the link in the chat to answer the survey. It's a short survey. I will give you 5 minutes, and then we are going to start the questions and answer session. I see that there is one question for Frederico. I have another from Professor Rust. I have to ask to all the speakers, Mr. Rust, Professor Rust, and Eduardo, to open your cameras to see. Eduardo has already opened. Professor Rust, as a good computer science researcher, has problems with computers. In Brazil, we have a common phrase in place of, I don't know how to translate in English. Let me see in the Google Translate. Casa de Ferreira, espeto de pau. Não traduziu.
En español es en casa de herrero, asadón de palo.
Yes, exactly. It's the same. I think that the Brazilian is not.
The translation would be something like, you can't take coal to Newcastle.
But it's the same. He's trying to open the camera. Let me see if Mr. Rust is already here. He tries to. Admitir. The first thing of a computer science is also to close the computer and start again. But as if the people should already have Professor Rust, you could open your camera now. Okay, we don't manage. I have Professor Rust, are you there? You are listening? Also no. So the first question is to the people could put the questions on the chat and on the button questions and answer in the taskbar below here below. But in the chat, let me see. There is a question from to Frederico from Hugo. Felicitações por la excelente apresentación. Mi pregunta es cómo desarrollar.
Congratulations for an excellent presentation. My question is how to develop the solution, the cloud-based solution for the metrological proposal for the SIM region to guarantee scalability and the compatibility between laboratories and MNIs with different levels of digitalization. Federico.
Yes, thank you. I was listening to the translation. Yes, thank you, Hugo, for the question. I think it's a very important first point to sitting down while defining how to build this cloud solution. And my proposal is to standardize or to use an agile method that is known as BDD, behavioral driven development, in which we split down 3 specific kind of tasks. Let's say the developer, that would be whoever actually sits down and develops the thing, but also the product owner, that would be the RMO. So meaning those would be the requirements coming from the working groups and the task forces, because that's the product owner. That's the one that really wants to use the thing. And then the testers, and this to me is the key for this to actually work and make it very compatible in all labs, have to be the users of the platform in the NMI level. So basically the National Meteorological Institutes need to be involved in the development of this RMO solution, because that would be the key to make sure that the solutions are not only compatible, but also understood. And once they are understood, they will be used in a national level. So hopefully that answers the question of how to start engaging for scalability and compatibility.
Okay, I have also a question to Professor Rusti. Professor, are you listening us? Even if your camera don't open, I don't see his microphone. Let me try to answer. Could you tell the experience of Metro performing cybersecurity verification of the remote disconnection, remote reconnection for smart metering? Do you use indices of level for manipulation by cyber attacks in your reports? I think he managed to answer. I will ask him again, because I don't think that in Brazil we allowed a remote disconnection of cyber of meters. No, let me see. I know it's allowed. Professor Rust, I think the professor. I don't have this. Okay, I think he managed to. Hello? Hello? I think that one of the things that's more critical is to guarantee that the value that the measure presents is not out tempering. There's no change in the value. The problem I really don't know, Professor. It's hard. I should address this question to him after, and then this question was done by Romeo Cardenas. And there is another question. Do you know of the Brazilian Regulatory Institute, ANEL, compulsory demands to the manufacturers to perform cybersecurity tests of remote measurement of energy consumption before the meter being installed? In Brazil, this one I could answer. In Brazil, the responsible for the metering is the Metro. We have connection with the ANEL, and ANEL discuss with us in Metro what to do with the meters, but the responsible to guarantee the meter process is from Metro. Any other questions? I don't think that Professor Rush is managed to enter. One thing that I think that the organization of this conference will ask, Francisco, we are going to take photo this afternoon.
Okay. Well, please, if you can to turn on your camera in order to have a photo. We are more than 70 people here. Then I would like to take a nice photo from everyone that could be possible. Thank you very much for the people who is turning on their cameras. And I'm going to take the photo in 3, 2, now. And as this is very big photo, I will need to take another one. Please wait a moment. The second photo in the 3, excuse me, in 3, 2, now. Thank you very much. You can turn off your cameras, and thank you very much.
Let me try the last time. Professor Rush, are you there to answer the question? I don't think so. I would ask if Javier is in this room to make the closing remarks for the event.
Yes, Javier is here. Javier, we can't hear you.
¿Ahora?
Sí, ahora sí.
Okay.
Sí, yes.
Sorry. As Rodolfo was saying, you know, casa de herrero, asadón, cuchillo de palo, right? Sometimes technology plays you good jobs. Okay, what I was saying was, first of all, I like to thank all the SIM members who took the time to organize this great event. It has been 2 days of wonderful speakers, lectures, and knowledge transfer. That's what I have to say. Second, thanks a lot to all the speakers we have had among speakers and block coordinators, around 20 SIM members and also outside SIM members who have thought of a lot about how we have to go about step by step trying to get into this digital transformation. And Federico, actually, at the end, he had, I don't know who decided to put Federico at the end, but it was a great closing for all the other speakers, because he was kind of giving a roundup of everything we have to do. And I would like to also to close with that. There is no doubt that we are in a process right now in which we're trying, as the SIM region, we're trying to get into this digital transformation process or period or era. And to do that, we had to be able to understand what was that different that he mentioned at the beginning, and that has been mentioned through these 2 days. What was digitization? What is digitalization? And finally, what is digital transformation, I would say, for all our organizations? And we also have to realize, by listening to all the speakers, where each one of our organization is located at this time. And based on that, then we have to take the different steps to be able to reach to the level that we consider we will be able to reach in a certain period of time. And some of us has been working on process automation. That's something that we need. Some of us have been working still in the use of some digital platforms or systems that we need to work on to be able to get to that machine-to-machine communication that we need for the actual digital transformation processes. Later on, we know we have to get into another step, which I guess one of the questions were mentioning about that, and that's the inter-RMO data transfer or management that we will need to do. And actually, one of Hugo's question was about that. How do we go about, or what are the steps to actually get to this methodological cloud, maybe that we need to have to actually get, I would say, an RMO database that we can use. And that RMO database should later on go into an intra-RMO trusted database or trusted digital information system that we can all use. And that is just between us, or among us, I should say. SIM, all the other 5 RMOs, and within the VIPN concept. But one of the things that, and I would like to close with this, one of the things that I have that I believe we also have to consider, and sometimes was discussed over here, is what is the purpose, what is the reason for doing that? We know the technology, we know that there are a lot of organizations that are actually moving into digital transformation, but we also have to think of what we are pursuing by doing this. And that has to be end user equity, and I was also mentioning during these 2 days, end user confidence, and end user the availability to be able to have, I would say, an end user resource that could be a friendly user for all of them. So that's one of the things that we have to focus on. All the simple or complicated changes that we're trying to implement in our organizations that we have been discussing during these 2 days has to be done with just one final end. How, through methodology, we can try to provide a better and simple digital transformation processes, not just for the RMOs, not just for the NMIs, but also to the customers. So when we do all these processes and all these changes, we also have to consider those partners for which we have to work for. And those are the end user customers. We have to lead them, and we know some of them are not ready yet for this transformation. And I guess when we were looking at the pyramid scheme that we always have, yes, we noticed one thing over there. There are some RMOs that have to lead this transformation. The others have to follow little by little this transformation. And then all together, we have to try to lead the end users on this transformation that we know is necessary and that we know is going to take a couple of years for some of us, a longer term for others, but we have to go through it. So with this, I would like to just once again say thank you to everybody. Thanks for all the speakers once again, and thank you for all the more than 100 people, colleagues that have been participating during today and yesterday, because yesterday we have an average of 100 people. Today we have an average of 80 people plus. So once again, thanks to all of you, and thanks to the organizers to be able to reach to this point in which month after month we see that we're getting closer to that idea, that dream that we maybe 2 years ago thought that we were going to do. How do we go about getting to a data transformation within the SIM region? We are now, together with the help of the other RMOs, in a closer step, I would say, and we are now ready to go into the further steps. So thanks a lot to all of you. Thanks a lot for pursuing that. Thanks a lot for pushing these type of activities against all odds, and for becoming what we have today, a great MW Group 14. Thanks to all of you for doing that, because that has been helping a lot the SIM organization. Thank you, and have a good afternoon.
Pues muchas gracias a todos los participantes. Con esto terminamos. En un par de horas recibirán un correo electrónico.
I'd like to thank all participants. We will conclude now, and you will be receiving a survey for you to fill out, and we appreciate it if you can fill it out. Thank you very much, and good afternoon. And greetings to the translation team that always helps us during these events. Thank you, Sheila, and the whole group. Bye. Good afternoon.
Buenas tardes.